Hello, hello, and welcome. We're looking at our work for Wednesday. So just like normal, go ahead and get your warm-up done. You do need to pause this video and do your warm-up. You'll be submitting your answers as well. Once you're done with your warm-up, click play, and I'll go over the questions with you. All right, well, let's take a look here. So we've got two functions here. I've got function h and I have function f. So notice there are two different functions, and so we need to find the sum of their slopes. So if I look at function h, hopefully we can see that our slope would be 1, because that's technically a 1 in front of the x. And then if I'm looking at f, well, I don't know necessarily what the slope is unless we take 2 points. So let's say this is our x1 and our y1 and our x2 and our y2. And you could have used different points, as you know. And let's go ahead and do our formula. So 4 minus a negative 5, and then a 2 minus a negative 1. So on both the numerator and denominator, we're going to have plus signs. So 9 over 3, and 9 divided by 3 would be 3. If I need the sum, that means we need to add. So f of x, its slope was 3, plus h of x, the slope is 1. So my final answer would be 4. All right, well, let's look at the next one. What is the quotient? So quotient would mean that we are dividing, and we need the y-intercepts of h of x and f of x. All right, so y-intercepts. Well, for a y-intercept, remember that your x has to be 0. So if I'm looking at my table for f of x, that's actually going to be the easiest because I can see, okay, x right here is 0. So that means my y-intercept here is negative 2. All right, so then now for thinking about h of x, understanding that that 4, which is our constant, would be our b, and so that would be 4. So if I take and what is the quotient of the y-intercepts of h of x and f of x, so h of x divided by f of x, that would mean we have 4 divided by negative 2, and negative 2 is our answer. All right, hopefully that makes sense, and make sure that you follow up with me if you have any questions. All right, getting to our lesson for today. So today is day 2 of looking at arithmetic sequences. We started to look at this yesterday. We looked at 2 different formulas, explicit and recursive. Remember that your explicit formula is helpful if you need to jump straight to a term, like the value of a term, and normally it's a term that's kind of like further away from your original sequence. In recursive, we're using the previous problem. We're going to also look at a little bit of some application too, and making sure that we're making that jump. So let's first start off with a quick review of recursive. So there is a formula. You wrote that down yesterday in your notes. So first things we need to do is figure out the common difference. So remember that we're looking at a term and looking backwards to see like what happened. And if I'm doing the common difference, I'm going to be subtracting them. So if I take negative 15, and if I'm subtracting a negative 13, again, we would end up like adding that here. So negative 15 plus 13, that would be negative 2. And let's double check it. So let's make sure that each time as we move forward, we should be subtracting 2, yep, minus 2, yep, and minus 2. So figuring out the common difference, that's why we subtracted. And then again, negative 13, it was a negative. So we know that our common difference is negative 2. All right, recursive formula. So remember recursive is the previous. So in order to get some sort of term, because n would represent any sort of term number, you're going to need to go to n minus 1, because again, this is your previous if you're going back one term, and then you're going to add your common difference. And again, this is just what we would do in real life. We normally would just, keep going. Because notice, how did I get to negative 19? Well, I had to know the previous value. How did I get to negative 17? I had to know the previous value. So just building off of your previous. So if I need to find a of 7, because again, n would be 7, a of 7 minus 1, and then plus a negative, just minus 2. Now what this means is, in order to find the value of the 7th term, I need to know the value of the 6th term. Now recursive is helpful if I don't have like a large distance to go, but if obviously I have a large distance to go, then I need to be using an explicit formula. So this would be like a of 1, a of 2, a of 3, a of 4. We need a of 5, and technically a of 6. So minus 2 more would be negative 21. Minus 2 more would be negative 23. So negative 23 replaces my a of 6 minus 2, and so my a of 7 is going to be equal to negative 25. And again, we could have figured out that if we just went one more to a of 7 here, and we would have gotten minus 25. So just again, making sure you understand what this means. This means that the value of the 7th term is negative 25. All right, let's keep it moving. All right, so we're going to be writing the explicit formula. And again, we did this yesterday, but just making sure that we are keeping up to speed here. So looking for a common difference, hopefully we see that each time we are subtracting by 3. So I know that my common difference is negative 3. Now if we're doing our explicit, remember that's going to be our a of n is equal to a of 1 plus your common difference times n minus 1. So again, this is a formula that we should know and recognize. Now, if I just want to start off with the formula before we're actually solving for any sort of term, I know I can plug in a negative 3 for where the common difference is, and I know that my a of 1 is this negative 13. So I can just create my formula using that. Oop, and instead of a plus sign, I'm going to do a minus because it's negative 3 and n minus 1. Notice, what would I do to simplify? Well, I would need to distribute. So a of n is equal to negative 13 minus 3n plus 3. Combine your like terms here. So we're able to combine negative 13 and positive 3. And so our final formula would be a of n is equal to negative 3n and then minus 10. So this formula, I could always start with this big formula, which is fine. Or if you know your common difference, you can kind of make a formula that's a little bit more simple. Because now if I need to find a of 19, I'm going to use this formula. Well, a of 19 is going to be equal to negative 3. And then again, we're going to substitute n is equal to 19. So that's why we're going to substitute and put a 19 here. So now we just need to simplify here. So negative 3 times 19 is going to be negative 57, and that's minus 10. So a of 19 is equal to negative 67. And again, make sure we understand what that means. So that means that the value of the 19th term is 67. All right, go ahead and pause the video, and you're going to be trying this next problem on your own. So again, you're going to pause the video and you're going to try that on your own. All right, let's go ahead and look at an application question. So you visit the Empire State Building and you drop a penny from the top of the building. The distance the penny will fall is 12 feet for the first second. So we know, okay, first second. It's going to be at 44. And then, excuse me, not 44, 12, excuse me, 12. And then for the second, we're going to be at 44. And then for the third second, it tells us we're at 76. And then it says, and so on, right? Obviously, eventually this will like hit the ground, but notice how over the course of the seconds, we're getting a little bit faster and faster. So if we want to write a formula, again, more than likely, this is going to be the explicit. So again, we want to take A of n is equal to our first term should be 12. And then we're going to be adding that. We need our common difference. So we figure out our common difference. So what is happening here? Well, if we take 44 and we subtract 12, that's going to be 32. So let's double check. So if this is plus 32, let's double check. Is 44 plus 32? Yep, that's 76. So this works out. So I know my common difference is 32. Again, we can distribute. So A of n is equal to 12 plus 32n minus 32. Combine your like terms. So my formula here, I've got 32n, and then 12 minus 32 is going to be negative 20. So this is our formula. And again, we could use this big formula, but we're trying to work smarter, not harder. We want to know how far will the penny have traveled after 6 seconds. Okay, so we need to know the feet. So that means n is going to equal 6. So A of 6 is equal to 32 times 6 minus 20. All right, well, 32 times 6 is 192 minus 20. And so A of 6 is equal to 172. So we know that after 6 seconds, the penny will have gone 172, and this would be feet. All right, go ahead and pause the video, and you're going to be doing the next problem for me to check and look over. And after that, then that's where we're ending with practice and your instruction for today. Again, a lot of things from yesterday. And then in Canvas, you just need to complete your check for understanding. Your check for understanding is just 5 questions. So hopefully you get those things done and you feel successful with the skill, and because we're going to be moving on tomorrow. I will see you all on Thursday. Everyone have a great one. Bye.